Good evening, everyone. Welcome to 2011 Physics Revision. Today is 2022, 20th of September. My name is Mr. Chu, and we'll continue with last week. And this time around, we'll be doing structured question. Okay, so everybody, let's begin. You think don't make me happy for nothing, man. Okay, 1A we'll skip. Okay, we'll do 1B. Okay, whoever need help in A, let me know. If not, we just skip A. Let's do B now. Everybody quickly do. Okay, like previously, I don't have the answer, so I'll be doing together with you. Let me go and take my calculator. Okay, Oscar is doing A. Let's skip A. Can you all do B? Okay, pressure is the force exerted per unit area. Okay, so that's how you do number A. Okay, so the keyword here is unit. Don't just say force over area. You must say per unit area. Okay, so the keyword here is unit. Okay, a lot of students, they did not put in unit, then the whole meaning changes. Okay, do B, do B. That's the key thing I want you to do today. Do B. You think in this question, you round out to two single figure, then a bit doesn't make sense. Yeah, a bit doesn't make sense. So give an exact answer be better. And incorrect, you think? Even based on two single figure is also incorrect. Okay, Oscar, well done. Ryan, well done. Okay, you think your mistake is why is your cm to the power of -3? Okay, that is your mistake. -3 is milli, not centi. Okay, Ryan and how are we correct? Yeah, but your single figure is not so good. Because you can see in the question, this is to 1 decimal place. Okay, or 2 SF. This one is constant. Constant you ignore. Okay. This is also constant, you ignore. Okay, who just left the class? Okay, where are the rest of you? Okay, so the liquid pressure, okay, is equal to H rho G. Your H in this case is 0.60 meter multiplied by density, which is 1000, multiplied by 10. Okay, from here, you will get 6000 Pascal. Okay, then you add these two together. Okay, this is the same as 0.06 Pascal. And then when you add them together, this is to 1 decimal place. This is to 2 decimal place. And when you add them together, you use the minimal decimal place. So the total pressure of the gas, okay, will be equal to 1.0 times 10 to the power of 5 plus 0.06 times 10 to the power of 5. You will get 1.1 times 10 to the power of 5 Pascal to 2 significant figure. Understand? Okay, but for this question, if you give 1.06, I don't think you'll you'll not get penalized. Okay, so if you give 1.06 or 1.1, both of you should be okay. Okay, everybody okay? Give me a yes reaction if you're okay, then we'll move on. Okay, so the answer for this will be 1.1 times 10 to the power of 5 Pascal. Then remember to put 2 SF. Okay, Bei Kwan, I'm very concerned for you. So can you please participate? Okay, Ryan and Howard, you understand how to improve your answer. But if I don't think you'll get penalized if you give the answer. Bei Kwan, I want you to participate by not just giving me thumbs up, also giving me the answer, the working. Okay, using ideas about molecules and the definition of pressure, explain why the pressure of the gas in the container rises. Okay, I will skip this. Anybody need me to explain this question? When temperature increases, the molecule move faster, right? So when they move faster, the times that they will hit against the outside, okay, the surfaces will be also increases. So when there are more hits, the force increases, the area remain the same, and therefore the pressure increases. Okay, you explain something like this. Is that okay? Okay, let's go to the next question. Question 2. Okay, I will skip 2A. Anybody need me to explain 2A? Let me know. Okay, let's all do 2B. Okay, do 2B, the loss in gravitational potential energy between A and B. Okay, Ryan, your cross means what? Means you want me to explain? Okay, you just listen. The principle of conservation energy, 2 points. Number 1, energy cannot be created or destroyed. Okay, it can only be converted from one form to another. Okay, that is a conservation energy. Okay, now quickly do B part 1, everyone. Ryan, well done for B part 1. How about the rest of you? Oscar incorrect. Try again. Okay, I'll give you 30 more seconds. Big Quan incorrect. Okay, hold on for a while. Okay, I'm sorry. Ryan, I'm sorry. Your answer is incorrect. Okay. Let me just redo the thing again. Hold on. Okay, I'm sorry. Ryan, you need to, okay, your answer is incorrect. Oscar, you are correct. Bei Kwan, you are correct, but no unit. Yu Ting, incorrect. How well done. Okay, after you look at part 2, then you realize that why Yu Ting, why your answer and Ryan's answer, your part 1 is incorrect. Okay. So let me just move on a bit here because there's also a part C. Okay, then for Yu Ting, your answer is the answer it should be for part 2, correct to 2 decimal place, okay? Sorry, 2 single figure. The rest of you, can you continue giving the answer? Ryan, you try again for part 1. Okay, Yu Ting, your part 2 is correct now, but can you remove the loss in EP? That one can remove. Okay, Ryan, well done. Okay, can I have 2 students to give the answer for B part 1? Okay, B part 1, can I have Bei Kwan? Can you do B part 1 on the screen? And then for part 2, okay, part 2, can you have Ryan? Okay, both of you write your answer on the screen. Hey, right here, your handwriting like worse than mine. Okay, in exam is fine. I'll give you the 2 marks. But in between, can you write down the actual answer? Okay, can you put here 6480 joule? Then you round off to your final answer. Is that clear? Then you put your 2SF. Okay, Bei Kwan, can you do your working for part 1 on the screen? Hey, Ryan, why you remove your answer? Leave it there. Let everybody see. Chelsea, can you hear me? Okay, Bei Kwan, are you there? Okay, Bei Kwan, well done. But there's 2 things you can improve. First of all, can you add in the formula? And number 2, your unit as well. Is that clear? Okay, so how do you improve in the working? You can write down EP is equal to MGH. Okay, you write down the formula, then you put in your value, then your final answer. Okay, with the unit. So based on what you write here, I only give you 1 mark. Okay, Bei Kwan, are you clear? Okay, now everybody, for part C, I will not go through part C. You all know why the first answer you lose 54,000 joule, but you only gain 6,500 joule. Okay, you lost so much energy, but you only gain so much. So where did the energy go to? Okay, so you can actually write down energy actually is being lost as heat and sound due to friction and air resistance. Okay, as the cyclist move down the slope. Okay, is that clear? So part C, everybody okay? Can so I move on already. Okay, so can you all quickly tell me name a suitable type of thermometer to measure temperature X? Hey Ryan, why over the past 2 weeks suddenly become so powerful? Previously, I very lousy at it. Anyway, that's a good thing. Okay, I will skip A1 and 2. So can you all just calculate part 1 now? Okay, part 1 now. Quickly, everyone. Okay, I haven't seen the answer yet. Let me just give you the answer for this. So have you all learned this? Okay, so why is this type of thermometer able to measure a a rapid changing thermometer quickly? Okay, anybody else can improve my answer? Okay, for part 2. Okay, let me do. Okay, so for Chelsea, what are the type of thermometer that have you all learned before? Okay, let me write down a few type of thermometer that you have learned before. Let me write down for you all. Okay, Beikwan, very good. So mercury in glass thermometer is one of the liquid in glass thermometer. So you can use either mercury or alcohol. Okay, and the last one that you all learn that I mentioned here is the thermocouple thermometer. Okay, these are the 3 types. Okay, so for this case, you use the thermocouple because it's also small in size. Okay, so you can also say is that okay, its size is small enough to be fitted into the dryer. Okay, so only 2 persons have given me the answer for part B, part 1. Okay, let me read the answer. Ryan, you look at the question, everything is in 2SF. So you'll leave your answer in 2SF as well. Okay, same thing for Chelsea. Can you write down the temperature, not the difference? Okay, Yuting, well done. Ryan, well done. How about the rest of you? Okay, Chelsea, well done. Remember to put in the unit. Okay, can I have Yuting to write down the answer for B part 1 on the screen? Okay, for Yuting, I will need you to improve by writing the formula. Okay, so all of you learned this before. Q is equal to MC theta. Okay, your Q in this case is 2500 watt. Okay, sorry. In this case, it is Joule is equal to the mass. In this case, is 75 gram. Your C is 1.1. Okay, and your change of temperature is down here. Okay. Okay, so can you Yuting, put in the formula inside? Okay, so 2500 watt is a same meaning as 2500 joule every second. Okay, so in every second, there's 75 gram of cold air that emerges. Okay, Xiaoxing. So can you see in the question, Xiaoxing, everything is in 2SF, 2SF, 2SF. So your change of temperature will be 30.3 degrees Celsius. Okay, you change it to 30 degrees because everything is in 2SF. Is that clear? So your answer here, 50.3 is good. Then your final answer, you put 50 and that will be the answer. Okay, everybody understand this question now? Oh, okay. Can so let me continue. Okay, so explain why the water on the hands evaporate rather than boil. Okay, I'll skip this question. So who can answer this question? Why the water on the hand evaporate rather than boil? Do you know why? Okay, you can say that evaporation occurs at all temperature, whereas boiling occurs only at the boiling point. Okay, it only occurs at the boiling point. So therefore, when the water touches the hand, okay, it will take energy from the hand and evaporate. Okay, that's the answer. Okay, let me move on. Okay, so fast you are in wave already. Okay, we'll skip part A and okay, who can tell me A? One of you going to do A. Let me name one of you to do. Xiaoxing, you do A. Hao Rui, you do B. Okay, everybody going to do C1 and C2. Okay, Xiaoxing, you do A. Hao Rui, you do B. Okay, everybody do C1 and C2. Okay, how are you doing? Chelsea, can you write? Write your answer into the screen. Okay, Ryan asked me a question. How do you find the amplitude of a longitudinal wave? Okay, let me explain to you the definition. Then you can tell me what's the meaning of amplitude. Okay, amplitude means the maximum displacement from the original position. Okay, does that make sense to you now, Ryan? It's the maximum displacement. That's why you call displaced, because you're taking it away from its original position. Okay, so it's a maximum displacement from the original position. Clear now? Okay, so describe what happened to the distance between adjacent particles as the wave move through the medium. Okay, what happened in part A here is that, okay, what happened is that the distance between adjacent particles will increase and decrease okay, as the wave move through the medium. Is that clear? Okay, so everybody give me the answer for part 1 and part 2. Okay, how Ray, your part 1 is correct. Ryan, your part 1 is correct. Oscar, your part 1 is correct. Well done. Okay, write the correct form of accuracy. Don't just write the whatever answer that you think is correct. Okay, if the answer here is 2 significant figure or 1 decimal place, please write the same thing here. Okay, Yuting, well done. Ryan, well done. Oscar, your unit is wrong. Ryan, your part 2, your accuracy is not correct. Who else? Okay, so X, the maximum displacement, okay, this is the original position. The maximum displacement is this. So this is your A, because that's the furthest you can actually go. Okay, Ryan, that is not the correct accuracy. Okay, so if x to y is 6.0 mm, the amplitude will be 6.0 divided by 2, you get 3.0 mm. Is that clear? Then, how do you find the frequency of the wave? Okay, so this t here, this is your period. Okay, so to find the frequency, you need to find 1 over the period, which is 1 over 2.0. You will get 0.50 hertz, correct to 2 significant figure. Okay, same thing. This is also to 2 significant figure. Okay, so that will be your final answer. Everybody, is that clear? Okay, these are the final answer. And today I don't get actually responses promptly from most of you. Okay, so can I get the level up of responses from the rest of you? Okay, now next, can you all find the speed of the wave? Okay, we'll skip part 4. Can you find the speed of the wave? Okay, Oscar, well done. Ryan, well done. Yiting, well done. Okay, I want you to write down the formula. Beikwan, what's your unit? You want to give me this kind of answer, you must give me your unit. Okay, as well as your formula. Okay, so the only formula you need to know is this: V equal to F lambda. Okay, your F you have written in the previous working, which is this. Your lambda is your wavelength. Change everything to meters. Okay, to SI unit. So the SI unit for this is 0.4 meters. And then therefore your answer will be 0.20 meter per second. Okay, some of you tell me 20 cm per second also can. Okay, but you must show me your formula. Then you sub in correctly, then give me your final answer. Okay, Beikwan, can you please start to give me correct unit as well as the formula itself? Beikwan, are you okay? All right, so I'll just move on to the next question. Okay, let me call names, then you tell me how to do. Okay, let me call names. Okay, how will you do this? Ryan, you do this. Beikwan, you do this. Oscar, you do this. Okay, Chelsea, you do this. Yiting, you do this. Chelsea, can you write down the source and detector in your diagram? Okay, Ken. Okay, very good. Okay, Howray, Oscar, what's your answer? Oscar, can you write it down in the paper? Okay, very good. Yuting, where is your arrow? Oh, you didn't see the question. Okay, for satellite TV, it is not radio wave. So who else can help Oscar? What should be the wave? Okay, so for this question, it's like this. Your wave will actually go through your body. Okay, so it's actually microwave. Hey, Ryan, your word very big. Okay, so for satellite TV, okay, you use the microwave. Okay, so for radio wave, you use the radio wave used for TV communication as well as radio communication. How we ask me a question for part one, isn't it radio wave? Smallest frequency. Oh, okay. Howry, I think you're right. Ryan, your part one is incorrect. X-ray has the greatest frequency because it's very dangerous, right? So its frequency is very, very high. Okay, so X-ray is wrong. Okay, so what could be the answer for part one? Okay, so X-ray has the smallest wavelength. Okay, X-ray has the smallest wavelength. Okay, thank you, Howry. You're correct. So for part one, which of these component has the smallest frequency? Okay, so yeah, this one very distracting. Let me just erase. Okay, so it's radio wave. Okay, is that clear? Okay, so towards this side, the frequency go up. Towards this side, the wavelength go up, the frequency go down. In this case, the wavelength go down. Is that clear? Then microwave supposed to be here. Understand so far, everybody? Okay, why is ultrasound not a component of the electromagnetic spectrum? Okay, why is it not? Let me just quickly explain to you all. Ultrasound is a longitudinal wave. Okay? Understand? Well done, Ryan. Okay, let's me continue. Okay, you're supposed to draw and label the position of source. Okay, okay. Don't need to draw the arrow. Okay, let's continue the next question. Okay. Do you want me to go through A and B? If not, can you do C 1, 2, 3? Okay, can you do C 1, 2, 3? Everybody, you all may begin. Okay, when you give me the answer, can you also write down the part number? Okay, part 1, Ryan got correct. Well done. Okay, Bei Kwan, your part 1 is correct. Well done. Okay, Ryan, your part 3, you try again. Oscar, why your part 2 is in Joule? The question asking in power. Okay, Oscar, your part 2, part 3, try again. Okay, Bacon, your part 2 is correct now. Can you write down your question number next time? Ryan, your part 2. Okay, wait, Bacon, your part 2, the unit is still wrong. Ryan, well done for part 2. Hao Rui, your part 3 is correct. Okay, how about the rest of you? Qiao Xing, Yu Ting. I have not heard anything from you all yet. Yu Ting, your 1 and 2 is correct. Yu Ting, the last question is lightning strike. Is a lightning strike. Try again. Oscar, your part 2 is still wrong. Wait. Xiao Xing, let me read your question again. Okay, sorry, Xiao Xing, I think you're correct. Okay, Xiao Xing, the power I think is not right. Wait, let me count again. You hold on, I got a call. Okay, I'm back. Okay, sorry, Yu Ting, I think you're correct. You're correct. Sorry about just now. Okay, Oscar, your part 2. The first answer is wrong. Second answer now is correct. Okay, let me remind you again. I look at the whole question. Can you see this is in okay, this is in 2SF. This is in 2SF. This one you don't know. This one is a constant. Okay, so energy in this case, energy is equal to power times time. Okay, your power in this case 100 times time, 5.0 times 10 the power of 6. And then from there, you can get the answer. Okay, you get 5.0 times 10 the power of 8 joule. Is that clear? Oscar incorrect for the last one. Okay, let me give you the second one is very okay. Let me give you a formula for the last one. EMF, right? V, the formula is W over Q. W is work done. Okay, is work done. Okay, so from here, can you do the answer? Okay, then for part 2, the power okay, I'll hold on for a while. Okay. Okay, the power will be the total energy over time. In this case, you know that there are 90 lightning every 1 second. Multiplied by the 5.0 times 10 to the power 8. And then from there, you will get the answer 4.5 times 10 to the power of 10. Okay, what? Okay, you know why is 90 over 1? 90 is the number of lightning every second. This T is 1 second. Is that clear? Okay, so the answer will be 4.5 times 10 to the power of 10 watts. Okay, lastly, all of you try the last one. Oscar, can you try this again? Pei Kwan, what's your answer for part 3? Okay, so one lightning strike produces this amount of work, which is the same as energy. Okay, so your W here will be 5.0 times 10 to the power 8. Then what is your Q? Q is written here. This is your Q. Okay, your Q is 4.0 C. So therefore, what's your answer here? Okay, so most of you can tell me that 1.25 times 10 the power of 8 volts. And you all remember my question is they're all in 2SF, 2SF. So answer cannot be so specific to 3SF. So your final answer should be 1.3 to the power of 8 volt. You write down to 2SF. Is that clear? Okay, Oscar, can you change it to 1.3? Then at the end, put there 2SF. Ryan, you can do that as well, no problem. Because the formulas are all linked, so it's no problem. Okay, and let me see. Hooray, you understand? Change it to 1.3. Okay, Ryan used another method. Ryan used Q is it. But how you use Q is it? Okay, you know the Q. Do you know the T? You don't know the T, what the hell you do? Okay, so what Ryan did is this. Ryan find the current first. Okay, so the current in this case is 4.0 C every second. Okay, then he uses power equal to V times I. Okay, I think I'm getting confused already. So Ryan, don't use this method. Okay, don't use this method. Okay, so let me continue. The next question. Everybody quickly do the next question. Okay. Who would like to do part A? No, not part A, part B. Okay, can one of you do part B? The rest of you write down A. Or today Ryan very hardworking. And yet don't on camera. Don't tell me today eating or go toilet again. Okay, everybody, can you do part A? Hello, part A, everybody, I want to see some answer. Okay, you think well done. Okay, so the sides of A and B facing each other are light poles. And since light poles repel, magnet B will move away from magnet A. Is that clear? Oh, okay, everyone? Can? Okay, let's move on. Okay, you all want me to go through this? We have been going through this recently, right? Quite very common. Okay, let me just, okay, all of you do part C lah. C, okay, never mind, we just skip this question. Okay, let's do the section B. Section B. Okay, 9A, start doing. Yeah, you're with me. You don't know how to do this question or not? Okay, Oscar, well done. Later, Oscar, can you give your answer and copy and paste it into the screen later? Ryan, well done. But can you be a bit more specific? But for 1 mark, I'll give it to you the mark. Okay, you can be more specific by explaining how does the distance per time interval increases. Okay, very good for Ryan. Later you give the answer for part 2 here. Okay, Oscar and Ryan, you type out the answer and put it in the screen and show everybody. Hey Ryan, part 3 need to use the graph paper to count one. Part 3 is like practical. Yeah, 10 years ago, there is no practical, they actually do SPA. So I don't know why they got such question in the screen. Okay, for Oscar, can you type out the you share it in on the okay. Can you type it out onto the screen? Yeah, I'll do that for Oscar. Ryan, can you type your answer out on the screen for part 2? Okay, this is Oscar's answer for part A. Okay, so basically, okay, this is how the graph will look like. At first, it is like that. Then it reach a point where it has a constant gradient. When the gradient is constant, it means that the speed is constant. Is that clear? Okay, so how the graph shows that the shuttlecock reaches terminal velocity. Okay, basically, when the gradient of the distance time graph is constant. Is that clear? Okay, Ryan, you understand how to improve your answer for part A? Ryan tell me that use the info in okay. Then you need to go and calculate lah. Okay, so everybody okay for this? Okay, so to find the terminal velocity, you look at your graph where it's straight line, you go and find the gradient. Okay, so I'll just skip this. Let's continue the next question. You're supposed to go and calculate. Okay, now for part 4, I want all of you to try this. Just the part 4, that's all. Okay, everybody do just part 4. I want you to explain to me to see whether you understand the concept. Hello, where is everybody? Okay, Oscar, I will give you 2 marks. Well done. Okay, I want the rest of you to give me your answer. Hao Rui, Wei Kuan. Okay, Chao Xing, give me the answer for part 4. Okay, Yu Ting, instead of the word speed up, we can use the word accelerate. Okay, Yu Ting, I'll give you 2 marks. Well done. Wei Kuan, 2 marks question, I'll only give you 1 mark. Okay, so this is the shuttlecock. You'll have a weight. Then there's also the air resistance. Okay. So how do you explain from here? Okay, so how do I write this answer? As the shuttlecock accelerates. Okay. Then what do I say next? The air resistance increases. Okay, so the air resistance will increase until it is equal and opposite to the weight of the weight. So when the resultant force is 0, there will be no more acceleration. Thus, terminal velocity is reached. Is that clear? Okay, let me go on to the next question. Oh, okay, so I'll just skip the rest. But if you want me to explain, tell me, just ask me to pause. Okay, let's do this one. Okay, all of you do this, write down your question number and then your answer. Oscar, initially it will not be slower acceleration. They will both start off at same acceleration, which is 9.8 times 10 to the power of, 9.8 G. Okay, start doing this question. How Ray, your significant figure is not correct. Okay, Oscar, your A is correct. Well done. The rest of you, what's your answer? Hello. Part A shouldn't be hard. Okay, you think part A correct? Well done. Oscar, part B1 correct? Oscar, your B part 2, well done. Well done, well done. Hey, how about the rest of you? Pei Kwan, Hao Rui, the rest of your answer? Xiao Xing, how about you? And Yu Ting, where are you? Okay, so for part A, let me give you a clue. For part A, use this formula, P equal to VI. Okay. Hao Rui, well done. Give a question number next time. Okay, so for part P, okay, so from here you can see I is equal to P over V. So for P, this is your V, this is your V. Okay, your power is 100 volt. Sorry, 100 watt. Okay, so your power is 100 watt, your V is 240 volt. From here, can you find the current? Okay, Pei Kwan, try that again. And Ryan, why your ohm so specific one? I got call again. Hold on. Okay, Ryan, your ohm is not correct. Can you try again? Can you try again? Pei Kwan, your Q, can you complete one more time? Okay, so from here, let me give you all the answer. Okay, this one will be 0.42 ampere, 2 SF. This will be 0.25. Okay, the last one will be 67 ampere, 2 SF. Is that clear? Then for the resistance, can you find the resistor at B? Ryan, your resistor at B is incorrect. Can you try again? Yuting, your resistor at B is incorrect as well. What is the formula? Okay, B1, Yuting, what's your formula for that? I don't want, why you have 580 times 0.25 over 0.42? Can you try again? Okay, so in this question, you need to know that R is equal to V over I. Can? So at B, your voltage is 240 volt. Your current you calculated in the previous question is 0.25 ampere. From here, what is your answer? Okay, Yuting, can you try again? Ryan, your ohm is wrong for part 1. Okay, Yuting, well done. Okay, so for part B1, what's your answer? Okay, you will get 960 ohm. Okay, last question before we call it a day. Calculate the total resistance of A and B in parallel. Okay, so what's the formula? 1 over total resistance is equal to 1 over resistance 1 and 1 over resistance 2. Then you make total resistance as a subject. Then you get the answer. Okay, so what's the answer for this? Oscar, you can do that, but that one is you must memorize the formula lah. Okay, you must memorize the formula. Ryan, you never put down the 2SF. Okay, Ryan, you may go. Yuting, you may go. Oscar, you give me the answer already. Part two, what's your answer, Oscar? How Ray, you leave your answer to 2SF. Try again. Oscar, you may go. How Ray, you may go. Okay, left with Bei Kwan and Xiao Xing. Okay, the other way you all can do, which I don't recommend, is you can use this answer. Okay, then you use R is equal to V over I. Your V is 240, your I is this answer. Okay, and then you find the final answer. You can do that as well, but I don't recommend. Why? Because this answer is not accurate. Unless you use the accurate answer in your calculator to calculate, then your final answer put to 2SF. Okay, so Bei Kwan, what's your answer for part 2? Okay, Pei Guan, quickly calculate. I will give you this. R1 is 580. R2 is 960. So what is RT? Yes, so can you make R the subject? And that will be your answer. Hey, Pei Guan, waiting for you. Okay. Pei Guan, 1 over R, if you add them together, what do you get? Use your calculator. 1 over 580 plus 1 over 960, what do you get? Okay, if I want to be very specific, I will get 77 over 27840. Do you get the same answer as me? Okay, Pei Guan. Okay, then to find error, you just invert it, lor. You will get 27840 divided by 77. Then from here, can you make it to 2 SF? Make it to 2 SF. Okay, well done. Okay, so the answer for this will be 360 ohm to 2 SF. Okay, you may go, Pei Guan. Thank you, everybody. Good night. Goodbye.